Okay, so let's try this one, and this problem actually borrows a concept from Physics 1, so try to remember as much as you can. That actually involves Newton's laws of motion. There's a couple ways you can do this. I want to use just one approach. Okay, so first let's identify what we're given. Um, we're given speed in this case. Actually, this is initial speed. Okay. We're given electric field strength, so that's just the magnitude. We're given the mass of an electron and charge of an electron, which initially is negative, right? It's an electron. Also, if you read the problem carefully, notice that something, in this case a force, brings an electron to rest. So that means the final speed is 0. And what are we looking for? Well, if you can look from the choices, it's one of these is the answer. All of them are units of time, and sure enough, it says how long. So let's write down all that we're given. Everything. That's initial speed. Electric field. That's uniform. That's good to know. Final speed is 0, and then we're given the mass of an electron. Now, I've memorized these, so I'll just write them down. And the charge of one electron is 1.6. I'm going to argue that it's actually supposed to be negative. And our goal is time. Formulas, we're going to need a few. Actually based on Newton's second law of motion, and we're going to need formula for electric field. Okay, in this case, our Q naught, as a matter of fact, is just simply going to be E, and it's actually going to be a negative E too. Right? So we're going to combine these two, as you can kind of see what they have in common. That here, the only force that's going to stop the electron actually is going to be an electric force. So let's solve this out. I just may have enough room to do this all on one slide. Okay, so first, I'll play around with this. MA, but acceleration is delta V over delta T. Or in this case, it's just T and EF minus VI. But what is our final speed? It is 0. So we actually get negative MVI. Where did the negative come from? It came from right there. Divided by time, which we're looking for. And then electric field. But using our second equation, E equals FE over minus E, we'll multiply both sides by negative E, and I'm going to get the fact that negative E is equal to FE. Okay? I'm going to plug this right in there. Okay, so E. Wait, I got a negative on both sides becomes positive. Okay, and what are we solving for? We're solving for T, so I'm going to move all that up and bring all of this down. So it's MVI E. Okay, so we're already ready, and this is actually the mass of an electron too, by the way, because that's one's in question. And so let's write all the numbers out. All their glorious numbers. Pardon my handwriting. Let's avoid parentheses. Remember our given, meters per second, and electric field strength is 500 newtons per coulomb times 1.6 times 10 to the negative 19 coulomb. But wait, Newton, what is Newton equivalent to? It is actually equal to kilograms meters per second squared. So a lot of stuff can cancel out. The coulomb goes out, kilogram goes, meters and meters go, and 1 of the second goes away. Wow, that's fast. So one of the only unit left behind is second, which is exactly what we want. Okay? I can show the unit analysis a little bit later, but let's solve this out. And, well, I've actually done this already. You get you get 2.2775 times 10 to the negative 8. But all are given is pretty much in 3 sig figs. Actually, only 2. Actually, only 1. That's the answer is in 2, so let's just keep it like that. And the units is in seconds. So there you go, read it and weep. Going back, what is our answer? Our answer is A. Okay, so let's do that units thing really quick again. Let's write down the formula we had. Mass, VI, electric field, essentially that was a charge. Okay, for mass, I get units of kilograms, scientific unit. Velocity was meters per second. Electric field was Newton over coulomb times Q, which is a unit of coulomb. Okay, so I'm going to keep that there. Well, I can already cancel out the coulomb. I have kilogram, meters per second, and Newton, 1 Newton, is equivalent to kilogram, meters per second squared. You can see that that goes away, and even the second goes away. So we're only left with 1 over s on the bottom, but you take the reciprocal of that, and it becomes a unit of seconds. Okay? See that? Stop there.